All right. Hopefully the audio is recording this time. It wasn't last time, so people who are not in this section complained. Um, just because they only see slides they could already download. Anyway, they did fine on the exam anyway, so apparently it didn't make too much of a difference. How did you find the exam? Any advice for us going forward about constructing exams for future generations?
I
Yes.
don't think there wasn't enough time to solve the
To solve.
second half of the
Yeah.
exam.
We actually made it much shorter than it had been in previous years. We've been cutting it down, and this time was the biggest cut. So it's cut down to about 12 pages from what was about 16 or 17 pages. So we tried to make it shorter so people would have enough time to complete the problems and to make the problems more straightforward. But maybe there's still more we could do in that area. Any other comments on the exam?
The beam search question, beam search is not covered in lecture or
Oh, so he didn't mention beam search.
No.
So, that is unfortunate. So it's in the new version of the textbook in the HMM chapter. But I didn't actually check. I didn't come up with that question. I vetted the questions, but I had assumed that the person who came up with that question had based it on what was in the lecture material. So that's something to take into consideration.
is the final exam inclusive?
Yes. The final exam will be comprehensive
And 3 hours long.
and 3 hours long, yes. And roughly twice the length of this exam. So, lots of fun. I can tell you're all looking forward to it. Yes.
So in the grading, if the question is not covered, then can we turn it into a bonus question so people don't?
Well, so the effect would be, because the final grades are effectively curved, then if we make it a bonus for everybody, I guess we could just make it bonus. If we give the points to everybody, then we end up not really affecting the total, and it's a one point question. So the effect is not that large, but we'll make sure that a similar question that in the final that there aren't any questions that were not covered in lecture or in the textbook. Although the textbook is fair game, as is the lectures.
Are you talking about the beam search question?
Yeah.
Because I think it was one of the open-ended questions for the
Okay. So I haven't had a chance to check the current version of the textbook, but that is in the new version of the textbook in the HMM chapter, discussing the advantages of beam search as opposed to Viterbi. Anyway, yeah.
How are midterm grades calculated?
Yes.
Oh, how were they?
Oh, how are they calculated? They're simply a raw total of the number of points that you get. If you'd like to see your midterms, so I would like to distribute them, and Professor Black is not on the same page necessarily there, but you can see them and take pictures of them if you will contact a TA, so they can have them in office hours, and you can look at your exam and see how it was graded.
I think I want to ask how mid-semester grades are
how mid-semester grades work. So there's a post about this on Piazza, but basically we sum all of the segments with the weights that are given in the syllabus. We drop two or one homework assignment and two quizzes, and then calculate a score for each student. Then based on those scores, then we identify, we apply a procedure that allows us to identify groups within the sets of scores where there are where there are breaks dividing them from other groups. The highest group gets assigned A, the next group gets assigned B, and the next group gets assigned C. And any outliers below that are assigned Ds. So that's the procedure by which they're defined.
Okay.
Yeah.
So what happens with the bonus grade for the assignment?
Then you just get over 100% for the particular assignment. If you had more bonus points, if you're the sum of bonus plus the score on the assignment is greater than 100, so that just goes into your assignment total.
So if you are clustering different groups, so won't it shift a person's cluster to the next higher one, because now you're taking the sum of all the assignments, right? So how is the bonus calculation done?
So if you get bonus, then it should it should potentially be able to shift you to a higher category, because you should get a higher, if you're getting bonus points, you should get a higher grade, and that should
But because this is curved, right? So isn't it just saying that the total score is whatever the bonus is? Because if everyone does the bonus, then the person who does not do it is essentially degraded.
It is true that somebody who doesn't do the bonus suffers, and you should do the bonus questions. Yes.
Can you post the midterm score on Autodive or Canvas?
I will talk to the TAs about posting it on Canvas. Yes.
Does the bonus carry over to the other components? Like if you have 140 over 100 on your assignments and you have a 60 on 100 over in your exam, so that bonus carries over, like it adds to
The bonus doesn't. The bonus adds to your total,
over.
so it's potentially possible to get over 100% on the homework portion, and then that would affect your the total after a weighting is applied. So yes. Any other questions about the midterm? I spent about 8 hours grading the FST problem, which I didn't think it would take that long, but it did. And I saw a number of really good solutions and a number of really convoluted solutions. So there's some people who I thought, I would like to see their code. It must be beautiful and elegant. There are some people who I thought, I hope I never see their code. So let's talk about natural language semantics, specifically lexical semantics. So far we've talked about a variety of different topics. In the second lecture we talked about information extraction. Subsequent lectures we talked about morphology, about language modeling, about classification, about syntax, syntactic parsing, We've talked about all of these different things. And now we're going to talk about something that matters. That is, we're going to get out of the realm of linguistic form into the real world. We're going to talk about semantics, which basically mediates between things like morphology and syntax, the forms of language, and reality. At least larger aspects of the world than are contained in grammar per se. So in a sense, the things that we've talked about so far are meaningful only insofar as we take semantics into account at some level. Without semantics, then the other stuff is meaningless. Anyway, sorry. So here's what we're going to talk about with regard to semantics. We're going to start by talking about lexical semantics in this lecture, and we'll continue in the next lecture to talk about lexical semantics in the guise of word embeddings, which everybody talks about all the time in NLP now. Then we'll talk about model theoretic semantic representations of sentences, and then about semantic parsing and semantic role labeling. So that's kind of a roadmap for what we'll be doing in the next set of lectures. If we want to look at meaning, then there are, especially lexical meaning, then there are three major approaches that we could take. One of these is decompositional, which is basically you break the meaning apart into constituent pieces, and you talk about meaning of a word or meaning of a sentence in terms of these pieces, these components, these features. Another approach is an ontological approach, where you talk about meaning in terms of how, for example, with words, you might talk about how the meaning of a word relates to another word, and use that as a way of talking about the meaning of that word. You have these kinds of networks or ontologies where each item, each word is given a place and put in relation to these other things. Then we have distributional approaches to semantics. And their meaning is defined by what context a word is found in relative to other words. So rather than having a big graph that defines semantic relationships between words, which you would have in an ontological approach to meaning, then you talk about what words occur around a word. What words does it co-occur with? As a way of getting at, it's doing that thing again, what the word means. So let's talk about decompositional semantics first. So here's an example of semantic decomposition. We have 4 words: boy, girl, man, and woman. And we have, these are written in linguist style. It might not be obvious to you what this means, but the plus means it has this attribute, and the minus means it lacks the attribute. So a boy is something that is human, that is not female, and that is not adult. And a girl, by contrast, is human, is female, and is not adult like a boy. So this gives us a way of capturing the relationship between boy and girl in terms of these primitives, these semantic primitives, and also the relationship between boy and man. So that's decompositional semantics. That's how it works. Yeah?
This assumes that they're like binary attributes. Is there a way to encode them with...
You could have like scalar attributes, or some other representational scheme, but most of these schemes have, basically been binary. So it's presence or absence of some feature. But it would still be decompositional semantics if you said, it has value 0 or 1 or 2 instead of just plus or minus.
Mm-hmm.
So what advantages do you see in this kind of semantic representation? Anything interesting that you see about it? Yes?
You could encode it as a vector?
Yeah, you could give basically a vector encoding to each of the words based on these the set of these features, and there would be many more than this. But yeah.
You can also tell how similar they are with some measure of vector distance.
Yeah, so what kind of measure would you use?
I mean, you could use Hamming distance if you wanted each one to be weighted the same. Or
Yeah.
you could weight each difference depending on how important they are.
Yeah, if you didn't want them differently weighted, you just use Hamming distance, and you could use it as a distance metric for these. So those are advantages. What do you see as disadvantages of this kind of semantic representation? What is problematic here?
It's limited by the attributes you list out here.
Right. So you're assuming a fixed number of attributes, probably, right? Especially if you want to do any nice vector manipulations on them, and that limits you. Yeah. Right.
Yeah, I think part of that is if you're trying to compare words across a variety of domains, then your length of your vector is going to blow up really fast.
Yeah, so you have to manage, if you're trying to do all of English, or even all of English within a particular domain, you're going to have a very large number of features. These are going to be very high-dimensional vectors. What else? What is problematic about these?
They only capture like a single meaning of a word.
Okay. As they are given, they only capture a single meaning. Although you could imagine that for a word, then you have more than one vector. And for each sense of a word, you have a vector. So that's not a deep problem, but that's something to consider with all theories of semantic representation. Yes?
It's hard to decide what components or attributes we chose for that word, and it requires some expertise.
Right, who does this? Who comes up with the master list of attributes, the master list of features? How do you decide what goes on that list and what doesn't? How do you decide where you break things down? Do you have a separate one for human, or do you have one for mammal and hominid? How do you justify in a principled way how this is encoded and how these different features are broken down and delineated and established?
Yeah, I was going to say, it sort of could be recursive, just similar to what you were mentioning.
Right. So it's a problem. It's interesting, but for reasons that we've discussed, decompositional semantics are actually the least used semantic model for lexical semantics, in particular in NLP. So that brings us to ontological approaches to semantics. Who here has done anything with ontologies before? Who here knows what ontologies are, at least? What is an ontology?
Relationships.
So it's about relations, right? And so what kinds of relations could be encoded in an ontology?
For example, you are a professor, we are students.
So there's So there's some sort of, we could have is student of relation, and then each of you would be in an in student of relation to me and to Professor Black. And that would be a kind of ontology. There are all kinds of ontologies used for all sorts of things. And one thing that they're used for is characterizing lexical semantics. So basically what you end up with when you construct an ontology, you have a bunch of relations, you have a bunch of entities, and you have a bunch of relations between these entities. And you end up with a graph, basically, of some kind, typically. So when we're talking about lexical semantics, we're talking primarily about semantic relations. And you may have learned some of these terms when you were studying in grammar school or when you're studying for standardized tests. So probably, who here has heard of the word synonym? I assume everybody. Antonym? Hyponym? Hypernym? Meronym? Holonym? Meronym?
Membership of something.
It's a part-whole relationship, so it's a part of relation. Yeah, so these you've probably all heard of. I think everybody raised their hand. These are relations that are also important in lexical semantics that you may not have been familiar with prior to this class, but which you will very soon become familiar with because I am going to familiarize you with them, and you are going to listen and interact. And you will like it. Yeah, so synonymy is easy. It's just equivalence, right? And antonymy is also easy. It's just about opposition. What is hyponymy? What are hyponyms? If A is a hyponym of B, then what is true of A? Yes?
A is a subset of B.
Yeah, so if we view A and B as sets, then A is a subset of B. So what is an example of a hyponym, hypernym? Because that's the inverse here. Hyponym, hypernym relationship. Yes?
So like boy and human. Going back to
Yeah,
other example.
a boy is a hyponym of human because a boy is a human, basically. And human is a hypernym of boy because the set of humans is a superset of the set of boys. How about meronyms?
Composition.
It's kind of like composition. So it's as it says on the slide, it's a part of relation, or the inverse. Holonyms are. This is a has-a relation. So if you what yes.
So the last one, they're mostly for nouns?
They can be for nouns or for verbs. It's easier to establish them for nouns, but so you can imagine cases like this for verbs as well and adjectives. So who can think of for adjectives, it's easy to come up with synonyms and antonyms. So, what's an adjective synonym antonym pair? synonym pair and an antonym pair. 2 pairs, sorry.
Those ones are adjectives, small,
Small, little, small, large. These are synonyms and antonyms. What about hyponyms? This requires you to think a little bit more abstractly. So think about colors. Yes.
Being red and being colorful.
Okay, so being colorful could be viewed as a hypernym of red. But even within colors, what about like red and scarlet? So what is the relationship between red and scarlet?
would be a subset of that.
Yes, something's for all x if x is scarlet, x is red, but it's not the case that for all x, if x is red, x is scarlet. So there's a hyponym-hypernym relationship there. For meronyms and holonyms, though, where it's part whole, then it's hard to have parts and wholes of things that are not entities. So nouns, these are typically properties of nouns. And I can't think of a counterexample to that. But so your point stands, at least in part. So here's an example of a little ontology. So we have here at the bottom wall as a verb and surround as a verb. And these are related to one another by a relation of synonymy. All of the arrows and lines actually represent relations, though. So what other relations do you see there? So note that these are given in the form of WordNet entries, a WordNet synset. So you have the part of speech after a dot, and then the number of the sense after a dot. So this is door, the first sense of a noun, of door as a noun. So what other relations do you see there? What is the relationship between door and building? So door is a meronym of building, and building is a holonym of door. What about door and wall? That's a hard one. Let's talk about fence and enclosure.
Fence is a hyponym of enclosure, and enclosure is a hypernym of fence.
Yeah, so that's hyponymy, hypernym. What about build versus destroy? They're antonyms. So let's see how we did. So we got antonyms, antonymy, hypernymy. Is that a relation? Holonym and meronym for building and wall and so on. So who here has heard of WordNet? So WordNet is a good thing to hear of. What is WordNet? Well, WordNet is a lexical resource that organizes words according to their semantic relations. You know, but what is WordNet really? What do people use WordNet for? Yes. It's basically a thesaurus. It's an electronic thesaurus. So, in what sense? What kind of information does it have? You can search for synonyms, hyponyms, antonyms. You can search. It's basically an ontology. They don't like, WordNet does not, the people who produce it don't like the description of it as an ontology, but really it is an ontology. Anyway, and the idea in this ontology is that words have different senses. So for every word, it has a variety of different senses. And these senses are grouped together with other words with basically synonymous senses into what are called synsets. Now, synsets are not as exciting as it first sounds. They have nothing to do with sin. They have to do with synonyms. And if that doesn't stop happening, I'm going to crush my computer. So each sense is associated with a synset. And these synsets are then associated with one another through relations like antonymy, hyponymy, and meronymy. So you end up with a big graph of relations between words. What could you do with this? How could you use this in your projects? Let's say you're a really bad person. And I believe you are. What might you do? Yes?
When generating a question, you could take like a synonym and replace it. So you can't just do like a simple text search
Right.
to find the answer.
Yeah, so you could do other things too, along the same lines in order to reduce like the cosine similarity between the question and the passage that they're trying to retrieve. Yes.
You could do like not and then antonym.
Uh-huh.
You could do like basically any of these relations.
Yeah, so you could in some cases look for hyponyms, look at a hyponym and substitute a hyponym.
Although I think the prepositions you have to use might be like kind of different based on which words. Some words that only take certain prepositions.
Right. Yeah, so you have to be smart about how you do it, but there are various things you could do. So if you know that other people are doing this, then how might you defend yourself? What?
Do it too.
Also do it. Yeah.
You can engage in basically a thesaurus harm to add more and more synonyms.
Right. So this is the kind of take-home message. WordNet is a glorified electronic thesaurus. And here, just to show some examples, this is a list of the synsets for dog. And what you see here these are actually only the noun senses. There's also a verb sense. But you have the part of speech, the other words in that synset, a definition, and then an example. And all of this is part of WordNet. So you hear dog, and you don't think, it's just a dog, right? But actually, dog has a lot of different senses in English, and each of them belongs to a different sense set. I think it's sort of unfair that for men, then dog can be like, you lucky dog, but for women, then it's a dull, unattractive, or unpleasant girl or woman. So WordNet is very sexist. Or else English is very sexist. So here's another way of looking at WordNet, and that is through the lens of hyponymy. So there's, one way of viewing WordNet is a big tree of hypernym relations between synsets. So if we start with fish, and we look at the hypernyms of fish, the hypernym of fish, we have aquatic vertebrate. And if we look at the hypernyms of aquatic vertebrate, then we have vertebrate and craniate and chordate, and animal, organism, living thing, whole, object, and then entity. That's the top level hypernym over all of these things. So if it's transitive, so if aquatic vertebrate is a hypernym of fish, and entity is a hypernym of aquatic vertebrate, then entity is a hypernym of fish, right? So it's a big hierarchy. Another way of viewing that is this notion of thesaurus-based word similarity is in this way, where you just have a phylogeny, and that's kind of what the hyponymy hierarchy in WordNet is like. It's kind of like a biological phylogeny. In some cases, it actually is a biological phylogeny, because as you turn back here, it has vertebrate, chordate. It's sort of questionable, actually, from a linguistic standpoint. But there are things that you can do with this that are non-trivial. And one of them is it's possible to calculate the information content of words. So if you have entity, you have hill, which word has more content? That is, which word tells you more? Hill does. Well, what is it about hill that makes it have more information than entity?
It's more specific.
It's more specific. So how do you characterize specificity?
It's got more
Yes.
parents.
So it's got more
Further down.
parents. It's farther down on the hyponymy hierarchy. So this is the idea that you can characterize the information content of a word by taking the negative log of the number of words that are equivalent or hyponyms of a word, and over the number of words in the corpus. Over the vocabulary. And so you can see that the entity is rather low in information content, but coast or hill are quite high. Any questions about that? So why might it be interesting to know the information content of word, or the relative information content of words? Why would that be useful at all? Yes?
That could help for some classification tasks. So like if you're classifying a document, maybe you want more information-heavy words.
Yeah, so there are a variety of different tests where it might be useful to know which words are more informative. And there are other ways of getting at that, like TF-IDF. You talking about TF-IDF? Yeah. Anyway, but this is another way of getting at what words are informative in a query, or in when you're doing classification with a bag of words, and so on. You know, that having information content as a feature in a classifier could, in some cases, be useful. So in terms of using WordNet, there are various interfaces that are available. You can see a lot of these if you look at the WordNet website under related projects. So you know, they have WordNet interfaces for a variety of different languages, including OCaml, but also Java. What many of you will probably end up using if you use WordNet is NLTK's WordNet interface. And you use it kind of like this. You import it from nltk.corpus. And then to get the synsets for a dog, you just call it this way. And then it gives you back a list of these synset objects. And then you can then call methods on them to get the words that are related to them through the various relations. So that could be useful to you. So WordNet is a useful resource, but there are built-in limitations to this type of resource. What examples can you think of limits or limitations that would be inherent in a basically hand-engineered lexical resource like WordNet? Yes?
People with time and expertise to make it.
Right. So you have to have lots of people who have lots of time, who you can pay to make this these kinds of resources. They have to be trained or have to have the knowledge that it takes to do this. One of the problems with WordNet is some of the people who did, it's essentially a lexicography project. And some of the people who did it who worked on it were not particularly good lexicographers. And so there are some weird inconsistencies in how the data that you have to be aware of. You know, and that's a problem with you're reliant on human lexicographers in this case to do the work. And so they bring to it all of the limitations that they have as workers. Yes?
It would need to be constantly updated because, I mean, I imagine dog didn't always have all of those meanings. And
Right.
so it could be expensive to keep it up to date and difficult.
Right. In fact, it's very difficult once a resource like that is constructed to get somebody to pay you to keep it up to date, because they say, oh, it already exists. Why are we paying you? We're not giving you money. And so you get something like WordNet, and it's stuck in a sort of frozen state. Not completely. They've done various releases over time, but it certainly hasn't really kept up with or tracked the variety of different senses that words have come to have in English from when it was created. So that brings up a kind of related problem, which is, can you get every word? Do you get every word of English, put it in, do you get every word of any language, put it in a lexical resource like this? What is this problem with words that makes it difficult to do that? Yeah.
One problem is they're not universal, right? 'Cause, I mean, even if you look at like different regions in the United States, people will use certain words in the South, and they don't use them in the sort of West, and so like getting together like groups of people from every region to get every word from the regions is not feasible, and even then,
Right.
even there are even smaller subsets of people who use different words. It's just
Yeah, so there's all kinds of variation. It's also the fact that people are always just coining new words. Constantly. It's so annoying. And so you end up this ends up exacerbating general out-of-vocabulary issues, because new words are constantly entering any language. You can't keep up. So there are always going to be a lot of words that are not covered by WordNet and any other similar resource. Yes?
I'm thinking about how can this WordNet invoke those phrases?
Uh-huh.
Because it's only take care of the single word.
Right, so it's primarily words. It does have some multi-word expressions that are longer than one word, but primarily it's words. That's the name WordNet. And when you're trying to talk about multi-word expressions, then it gets even more complicated and even more difficult, right? And because they're even more freely added to the lexicon of speakers of a language. But you often have to, they often have idiomatic meanings. They're not predictable completely from the parts. And so you need them to be listed in a lexical resource, but it's really hard to do. So let's look at something else. Here is a set of sentences from the Brown corpus, which was the first large electronic corpus of English. And it's made with a concordancer. And this is a set of occurrences in no particular order of the word beef. So what do you notice about the words on either side of beef? Anything stand out? Yes?
By the second word that comes after the.
Yeah, that's true. I lied when I said it was in that particular order. So there are many beef-related words, aren't there? If you wanted to characterize the meaning of beef, how would this help you? If you didn't know what beef meant, but you knew what a lot of other English words meant, you're trying to figure out, what is this mystery beef I've heard about? How would this help you? Yes?
Well, if you didn't know what a word was, you want to go to the context of what the other words about it are, see what it's related to.
Right.
And help you narrow down what it kind of is related to.
Yeah, so what kinds of things is it related to?
Cattle.
Cattle, dairy cattle, dairy,
That's it.
fat, poultry, pigs, chicken. I have no idea why that happens. So let's look instead about chicken. A lower fat option, but not necessarily a less instructive one. What do we learn about chicken from its context in the concordance? Anyone care to do some dull silver chicken fencing? It's like, yes. Dinner. Yes. Fencing. Coops. Coops. Dinner. Farmer. Cadillac. So this brings us to a subject. It's called distributional semantics. And we're going to talk more about this in the next lecture, but this is just to give an introduction. So moving back in time, in the 1940s and 50s, there were a group of linguists in North America, especially in the US, called that we now call the American structuralists. And they were really interested in describing languages, especially the indigenous languages of North America, but other languages too. And they wanted to do so in a way that was rigorous. They wanted to be scientific about it, not like the other people who had come before, not like the missionary linguists who'd written the first grammars of these languages. They wanted to do it scientifically, and so they wanted to come up with ways of rigorously understanding what how a language was structured and what words in a language meant. And so one thing that they started doing is collecting corpora of texts. They didn't have very good means of processing these yet. The only means were called graduate students, which were inefficient and error-prone. But they ended up developing a set of ideas that have become enormously influential. And one of these guys was a guy named Martin Hughes, and he kind of first formulated what is called the distributional hypothesis. But the guy who really developed it was a guy named Zelig Harris, who was a professor at University of Pennsylvania. And in 1954, he wrote this paper where he pointed out that when we talk about two words being synonymous, then what we're really talking about is those two words occurring in almost the same context. That is, occurring with almost the same words around them. And that words were related to one another in proportion to how similar the contexts that they occurred in were similar. And so, if you could characterize, if you could look at the contexts of all of the words in a whole corpus, you could characterize how these words related to one another in meaning in a completely data-driven way, because that was very important to American structuralists, that it be data-driven. But Zelig-Harris was not, he was a very, he was very strong methodologically, but he was not great at clever turns of phrase. And so it was left to an English linguist by the name of J.R. Firth to coin the slogan that often gets associated with distributional semantics, and that is, you shall know a word by the company it keeps. So that's very clever. Zelig-Harris would have never come up with that. It's like a bunch of dry formulas and sort of tedious prose. Believe me. So here's an idea. So let's say you have a corpus of text. This is a hypothetical corpus of text. And oh, this is actually from Brown corpus. Okay, so we've got 8 dimensions here in the columns and 4 dimensions in the rows. And so basically, you identify a window of some size. Let's say our window size is 3. I don't know what the window size for this place is. You go through the whole corpus. You have a matrix that has a row for every word in the vocabulary and a column for every word in the vocabulary. And every time you come across a pair of words that are in that window, you add 1 to the corresponding value. Then you end up with these kinds of context vectors. Now, what do these tell us about the meanings of apricot, pineapple, digital, and information? Yeah.
Apricot and pineapple seem to be quite similar.
Okay.
Quite similar, but
so these 2 vectors are similar. These 2 vectors are somewhat similar. Yeah.
And they're pretty much opposite from each other. Like pineapple and
Right. So these are very far apart. So if we were to take some kind of similarity metric between the 2 vectors, then these 2 would be close together, these 2 would be close together, but these would be far from these. So that is in the in essence, that's a fundamental idea of the distributional hypothesis and of distributional semantics. Yes?
so when you're doing this, would you do, or maybe you do all of these? Because you could take a window size 3, say, and take the 2 words on each side. Or you could take the word before and the word after and have like a left distribution and a right distribution and like a total distribution. Is there like some standardized way of doing it? Like in terms of which words around it you choose? Or
so it's basically your counting the number of times that a word pair occurs within a window. So you're not looking at left or right
Okay.
context. You're moving the window across, and if they occur, if the pair occurs within the window, then you add one to the count. It's actually a little bit more. So the window is usually wider than 3.
Mm-hmm.
It's like, and the width that you use depends on what you want to do with the vectors. Generally, the wider the window, the more semantic-y the vector is, because it captures more of this contextual other vocabulary that's associated with that domain. Whereas if it's narrower, then it tends to capture more semantic information, like whether it's preceded by a determiner or preceded by an adjective or followed by a verb. And so that, there's people will use a different size of window depending on what they're interested in. But the way that, the way that they're counted is kind of brain dead. Although, we talk about just counting them at this point, but actually the way that word embeddings are created now, for the most part, using something like word2vec or fast text or whatever, then you use a different kind of model where you're essentially using a classifier that's predicting the likelihood of word occurring in context rather than just summing the words that do occur in context. So we'll talk more about that next time. So another way of doing this would be, rather than just looking at co-occurrence within a window, is to look at syntactic dependencies and see how many times, for example, a word was modified by some word, or the subject of some verb, or the object of some verb. And you can do something that's quite similar, and this has some advantages in that it has a disadvantage. You have to have a dependency parse of all the data. It has the advantage that you get a somewhat richer representation sometimes with a smaller amount of data. But so here, this is hypothetical. So lions are more likely to be modified by ferocious than elephants, and more likely to devour you apparently than elephants or cats, although they don't know the cats I've seen. You apparently don't pet lions. Anyway, so you could get, rather than having, you could have the words in the vocabulary in these rows, and you could have a set of relations in the columns. And that, too, would be a kind of word vectors, a kind of word embedding, because you're placing these words into a sort of vector space. But it's one that's a little bit more, a little bit higher level and farther removed from the data. So here's a problem. If you're doing these counts, then some words are going to occur a lot of times together just because they occur a lot. So like the and is, or they're likely to occur in the same window many times just because they are frequent. So how should we address this? What should we do about this? Any ideas? Any magic formulae? You could use something like TF-IDF. The TF-IDF is not really about co-occurrence, right? So we could take the vocabulary and we could weight things by TF-IDF, and then weight the co-occurrence numbers somehow based on that weighting. Any other ideas? Yes. Okay. Yes. Care to elaborate?
I don't know the way to calculate something similar.
Okay. I hadn't thought of that. It's an interesting idea. And I think that people have done that. But we're going to look at a different solution. And this is what is called pointwise mutual information. Anybody heard of PMI before? It's really simple. It's when I say that, what do I mean? When I say that something is simple? Me in particular. It means I like it. Anyway, I can understand. No, it's elegant. It's beautiful. So PMI is just this. So the joint probability of the two words occurring together over the product of the probabilities of the two words. So what is this? What is the effect of this going to be? So if W is very frequent, then PMI is going to be if W is very frequent, PMI is going to be what? So if we hold the frequency of F constant and increase the frequency of W, it's going to decrease. Yeah.
Increase at first and then finally decrease.
Right. So basically, what is this doing? Yeah.
Well, and once it has the nice property that if the two are independent, then PMI will be 0.
Uh-huh.
Between y of 1.
Right.
So it's basically showing their dependence on each other.
Yeah, it's measuring their dependence on one another. That's the whole idea. And that next time we'll talk more about some tweaks that you can make to PMI to make it work better. So one problem it has right now, so you can get negative, it can be negative, where you have things that are, well, it's hard to express an intuition. It's like they're anti-unrelated. So we have an additional, a revised metric called positive PMI that addresses that problem, basically by just establishing a floor at 0. But let's close by looking at some distributionally similar words. So if you have, this is from Big Corpus, and they started with words like rum, right, ancient, and mathematics. And looked at the N words, the K words that were closest to each of these words in terms of their vector representations. And we'll talk about how you compute this kind of similarity next time, if you don't already know. Spoiler alert, it's cosine similarity. What do you notice about these classes? So these are words that occur in the same contexts, or similar contexts. And they're ranked according to how similar the contexts are. What about rum? It always amuses me the detergent is there. What are these people drinking? Mouthwash I could see, but detergent? So what about ancient? Yeah.
Distribution is similar, but it doesn't necessarily mean like similar in meaning. So you've got ancient and old and ancient and modern. So you've got like a synonym and an antonym.
Right.
Very distribution similar.
Yeah, exactly. So you can say that old and modern, ancient and modern, are very closely related semantically, in that they have an antonymy relation between them, but they don't mean the same thing. You know, so they're related, but they're related in a particular way. And the with distributional semantics, it doesn't really allow you to tease that apart very easily. So what about mathematics? So why are theology and scripture in the same column as mathematics? Because they all bring you closer to God. Any other observations? You know, the thing that always impresses me about this is it actually works. You know, I mean, they're not perfect. You know, they're not perfect classes, but for the most part, everything here is semantically related in some way to the original word. And I find it remarkable that such a simple methodology, such a simple approach, such a brain-dead approach, could nevertheless produce such uncanny results. I just can't. I can barely contain my amazement. Anyway, every time I see this, you know, and this is something. So I've been working recently on a project with word embeddings in some other languages where we enrich them with other kinds of information, and like morphological and phonological information. And it's just impressive to me every time that I see them work, that they do work. You know, without having a human go and label a whole bunch of data, you can nevertheless get this improvement in performance in various tasks by giving it a word embedding that's just trained on a whole bunch of text. I know you're unimpressed, but but it's beautiful, and you should go out and download Word2Vec with fast text, or go out and make some word embeddings. Anyway, all right, we'll come back next time and we'll talk more about vector semantics. We'll actually go over again some of the stuff that we've already talked about with distributional semantics, but we'll talk about it in greater depth. So you'll get more formulas, more math, and come closer to God.